Did that put out the correct name now? I have no idea. Well, I'll be back. I'm gonna grab glass. It's carbonated water, by the way. I think you go do let's playing. Is it still saying that I'm playing that? I'm gonna just check on my actual channel. Sometimes it's misleading. No, now it says making Quadruped. Cool. Making Quadruped Part 1. Droid Repair Bay with Alan Wong. So I called the stream this time. Yeah. I'm kind of playing Droid Repair Bay, but in real life. So what I'm going to do is I'm going to unplug this servo that's connected to a bad leg. Unconnect these guys. One thing I also have to take a look at that's a mystery is the power supply of this servo motor board. Or I think that if I take a look at maybe the data sheet. Unfortunately, I don't have a schematic because I wasn't smart enough to do that when I made it. Okay. So, I disconnected the legs. Here's one of the legs, and we're gonna have to reprint the piece for it as well. The piece is this thing here. I'm gonna unplug that as well. They look like this. These pieces were really weird because like you were supposed to put them in hot water and bend them, but that ended up making them brittle. Like I was able to break it with my bare fingers. But we're gonna see what we can do. Maybe I'll just completely design my own because I've printed a couple quadruped bodies now, and unfortunately, there's not a lot of them that are great. So I think that probably designing my own is probably the best way to go, which is usually the case. Design your own stuff. You can only be disappointed in yourself. Okay, so here we go. We have the CERT TLC. What's the name of this chip here? It's called TLC 5940. TLC 5940 is the chip that I'm using. So I got to take a look in my library and look up the data sheet for this guy. Because oh, here we go. It's TLC 5490.pdf. Well named. The TLC 5490 is a 16-channel constant current sync LED driver. All you need to know is that you can run a servo motor off of this. But what we need to know is specifically this VCN, or was it VN? It's probably going to be a range. Power supply current voltage. Input voltage. Okay, it says here, I think, input voltage maximum 6 volts. So what I'm thinking that I was probably running it off last time was something between like 1 and 5 volts. So I was probably using those lithium-ion batteries that I have, and I think that I was running them in parallel. So that just gives us 4.2 volts, but hopefully a larger capacity. So let me. Am I arranged? So. I suppose I should draw a picture to explain what's going on with this droid. Ah, no. I lost my scene. Ah, now I'm tiny. Oh, no. Build stream. That's the one that we had. Okay, that's the one we wanted. Good. We're back. I actually wanted to go to paint. Use paint. Although, is there better programs for showing these kind of things?
What are you trying to show?
I guess drawing? I'm just trying to use paint like basically a blackboard.
Oh, like any kind of whiteboard program you can have. You can use paint.net tools. You can use CritUp perhaps.
Paint.net is better.
Yeah, a few more effects and stuff.
I also use Krita, yeah. Maybe I'll just use Krita. Okay, if I'm gonna let me think here for a second. I'm gonna have to change this one. Ugh. I have so many overlays now. I'm gonna try and make one that's specifically for doing Krita. I think that did it. I'm getting at least getting a little faster at making them now. There we go. Screw the rules. I have money. Oh, thank you for the tip, Lily Autumn West. I appreciate that. Thank you very much. Okay, let's add. We're gonna do Krita, right? So how do I add Krita now? Is it be a window capture? I guess so. Let's try it. Krita capture. Oh, Krita. It's not Krita. What the heck? This is supposedly Krita, but it's not Krita. Let's try this again. Maybe I should just do a desktop capture.
Mm-hmm.
I was going to capture a lot more than we want. No, this is not good.
Okay, well,
I
I have a camera here.
Oh, sweet.
Yep. So
Okay.
I should put a piece of paper and just draw things literally on a piece of paper.
Oh, that's a good idea. No, that's a great idea. You don't like the black screen? I'm sorry.
Eyeball pain was the fact that it just kept like going forever.
Sorry about that. It's because I just try to stream my own desktop. And that results in issues. There you go. I put the cat in the picture now. You mean the picture here? Yeah. The internet demands more cat, so that's better.
See, do you have Droid Cam client?
Yes, I do.
Okay, give us to disable my capture on this side.
Maybe just show it to me instead of saying it out loud.
Sure. Yep. So. Okay. Shouldn't matter because it's internal network, anyways.
Yeah.
Change the last one to 145.
Is it normal?
Yeah. Yep.
Okay.
Probably don't need audio and. Are.
Okay. So give me a second. I'm gonna actually put that in the stream now.
You
Give me a
can probably
second.
increase the brightness as well too on it. Go to controls. Go to the.
Oh, you have Pro?
Yep. Yeah, it has high res.
Nice.
Yeah. So go to
Autofocus?
autofocus.
Okay, good.
Yeah.
Good.
And then go to brightness. Should be able to adjust that. Just dots in the corner. Yeah. Increase the brightness. There, it looks better.
Okay, wait, let's put this in here so that everyone can see what we're doing.
Yeah.
Droid cam.
There we are.
There we go. Let me put this underneath everything. And let's make this bigger.
Adjust this
Like
around.
this. Oh, this is epic setup. Okay, let's make this a little smaller, okay?
Yeah.
Let's do it like, put us over here maybe. Okay, this is good. This is good. Okay, that looks sick. Look at our stream setup. It looks so professional. Okay, let's talk about what we're doing. Okay, so within our system we have. Should I draw?
Droid.
Oh, let's put the droid there.
Yeah.
Let's put the droid here. Okay.
So let's see here. So
Here's our sad droid. Okay, he's seen better days.
Yeah.
Last time we saw him, he was actually working. And what we're going to do is we're going to progressively upgrade this droid until we have a really cool spider droid. And the purpose is we want the spider droid to be our friend. We want our spider droid to be able to help us out.
Not to kill us in our sleep.
Yeah, not kill us in our sleep, hopefully. Okay, let's talk about how this works, okay? So, this thing here, this gray thing here, this is the programmer. You connect this to a USB, and it lets your computer talk to the chip here and reprogram the chip through the Arduino software.
Basic
Yeah, is it?
Yeah. go to
Here?
Droid
Dot,
tab,
dot, dot.
Controls down. Increase contrast.
Contrast?
Yeah. Decrease it. Actually.
Decrease it like that.
Ah, that looks better.
Oh, that does look better.
Yeah. There we go.
Okay.
Yep.
Perfect.
Yeah.
Oops. No. I don't
No,
want to
that's
cancel
all.
connection.
Yeah.
Sorry, that's a bad habit. Windows habit. Okay, let me bring the microphone over here so I can talk a little better. Should I move the mic or move the camera? Maybe
Table.
move the table.
Table.
Sounds good to me.
Yeah, I can move this around. Reposition. Center this.
Okay, so now this guy here, this chip contains our program or whatever we're going to run for the chip. Eventually, this is going to hold all of the walk cycle programs and stuff like that. I didn't really get that far with this project yet, but this will eventually hold all of the walk information, which servos to turn on when, you know, the sequence for moving forward and moving backward, stuff like that. Is also how we access the features of this guy, because this one is like a slave to this one. It's this is the master. I don't know if that's politically correct, but whatever.
This is war. You have to rephrase that.
Okay, so this is the boss.
Primary and secondary.
This is the primary and this is the secondary. This one does all the commands and tells this one what to do, because this chip over here is only for doing one thing, which is to converting like electronic pulses into pulse width modulation signals, which is how we control the servos.
So those servos are in the
legs.
Close. Look in the legs. So you flip it over, you can see these are servo motors. You see this little lever? That goes twists one way or the other depending on the pulse and stuff. These are all in stuff like model airplanes, model helicopters, model boats.
Yeah, and they're super useful for all sorts of applications, as I've been finding out. These ones in particular, I got last year or a couple years ago from AliExpress. So these actually worked really good, and they were pretty cheap. So free advertisement for them. They didn't pay me to say that. You can get good parts from AliExpress, but it takes a long time though.
Yeah, you have to wait on China time.
Yes. But you do save a lot of money in the long run, especially if you're going to be buying lots of components for doing electronics. Let's go into what we're going to do with this now. So I'm going to plug this into my computer, and I think that what I should probably first do is untangle everything and try to reconnect it, because I don't know if everything's connected even properly anymore. So this is the power jumpers. So that does need to be connected there. We'll do a smoke test, right, Alan?
Mm-hmm. Well, I hope it doesn't smoke your computer, just smoke the board.
Yep.
That stream's going to nail it early.
That's not even the first time. I had a couple games where I was playing them, and they were playing normally, and then I went to go stream them, and it bricked my computer. Like, a straight up brick my computer. And when I restarted my computer, there was no explanation. Usually there's an explanation like, oh, your GPU failed or whatever, or blacked out, or had an error. No, just restart and no explanation. And yeah. Games are funny like that. Especially new games can be really glitchy. But here we go. So we've got this guy going to here. And this programmer here is going to put our program inside. And I think that what we should just try and do is get this guy correct and working. I'm pretty sure everything's already connected up the way it's supposed to be, actually. I don't know if I'm 100% sure I want to trust myself, but I'm pretty sure last time I plugged it in, it worked. So maybe I should just trust myself. These pins down here need to be powered.
Okay. Yeah, so these little motors, they require an external source of power.
Mm-hmm.
Only body packs out.
Yeah, I can use I'm probably gonna use just instead of using 2P battery pack, I'll just do a single 18650 battery pack. So I'm gonna be right back while I grab that. I remember that using the battery on that was really powerful. But I could even maybe use something a little less powerful. Alan?
Actually, it shouldn't really matter. It won't draw so much current as it actually needs.
Okay.
In the meantime, so we're trying to organize our space here. Streaming. Work in progress. We have that. So, well, guess while Jordan's looking for a power supply, so we're gonna.
One of those 18650 battery packs.
All right.
Because they had like fuses in them. They were too safe.
So we'll just use. I guess you have some double A's or something. Yeah.
I have a bunch of double A's.
That should be fine.
This is going to be a double A battery pack. So 3 double A's in series, and so that's going to add their voltage together. They're connected like end to end. So the positive of this goes into the negative of that, positive of this goes into the negative of that, and so on. So we add their voltages, which is 1.5 volts, for a total of 4.5 volts. With the first one being 1.5, then 3, and then 4.5. And this little connector here is what gives us our power. I don't know if I can bring that close.
Yeah, it's like, pull it back so it's focused. Okay. Put this out of the way that you can see it. Right there.
Yeah, so this little connector here is what a lot of the 18650 battery packs that I was looking at downstairs were missing. And I didn't want to splice one off just right now in the middle of the stream. Because we're just doing some testing, right? So here we go. I'm going to hook this up to the power of this. And I'm wondering if I should maybe unplug it from the Droid, but you know what? I'm just going to do it. Although, wait. On this one, I didn't mark which power here is, which one's power and which one's negative. That's bad.
Trace it through the circuits to see.
I can see one thing here is that I did put a blue wire. Let's see if I can show it off. There's a blue wire here at the back. I try to color code my stuff in the correct way because I remember when I first started doing electronics, I didn't do that. And I just used random wires, yellow, green, blue, whatever wire I could find for whatever connection I was going to do. I find that if you take the time to color code your wires, Ooch is right. Yeah, if you don't color code your wires, it's like shooting yourself in the foot. It's like doing code without leaving any comments. It's color coding saves time, and it's good for you. It's like it's like eating your vegetables. You got to do it. It's good for you. And when you come back, you're gonna wish that you did that if you didn't. So this little color coded wire, I'm gonna take a look here and take a look at which one of these prongs this little blue wire goes into. Which I think what I'm seeing is that it's going into the rightmost prong here. So it's going all the way across here and out of this prong on the side. Here, that one. So that means that I can plug this guy in like this. You see this black wire here? As long as that black wire lines up with the blue wire up there, then I'm sure you're good. Another thing, the way that I'm checking here is that this wire is also going over into the negative side of this capacitor. So that's just more reaffirmment that this is the ground side. So here we go. Smoke test.
So I guess no
We're good.
pulses are going to, so therefore no motion.
Yeah.
Looks like,
Okay. So now we got to hook this guy up to the computer, which I have to go look for a USB cable, and I'll just be a moment. I think I have one inside of that box over here. Okay, thank you. No, I have one. Well, I found another one of those cables. Here we go, Alan. I found one. Okay. So that's going to go right here. And then I'm going to have to go grab Alan because I don't know if you heard me and I don't want to shout across the entire house. Come on. Here. There we go. Oh, it's working, Alan. It's running through the last program that was on there. It's moving. It's moving. It's alive. It's alive. It's alive.
Please don't kill us, Mr. Robot.
It's alive.
So now that you found which one's plus, you probably want to mark it.
Yes. Good idea. I think that the program has ended. Or there's like a loose connection somewhere. Yeah, let's mark it now. Let's see here. So this is negative, and this side is.
Yeah, it's kind of spooky. It's driving like a dying animal.
Yeah. Oh dear. Okay, so well, it's confirmed that it's working, and it doesn't seem to be doing. Although it is doing a concerted kind of movement here.
I think you probably have the same cycle of movement that's probably looping over some angle.
Do you think maybe I should try and print the same parts and just repair it with the parts?
Okay, let's actually show people how you 3D print stuff then.
My question here is, these parts were not good though. They were kind of a pain in the butt, and they didn't fit very well. I had to like, what's it called? I had to sand them a lot.
So you may want to remeasure them and get a more exact measurement.
Yeah, or make them better.
Yeah, it's better mount.
Better mount, at least for the legs. Although this is kind of spooky, isn't it? It's writhing. That's probably where we should start, is trying to do a full body rebuild of this guy. So I guess that's what we should do tonight, yeah?
Yeah.
But look, it's moving, Alan, right? So this to me, when I first did this, even though it was like kind of horrific, this to me was a major achievement. Because like, not only are they moving, but they're moving with the program that I put inside of it. Which, like, again, it's not walking, but it's something, right? This was like my blink circuit for the poor robot. This is as far as he ever got. I think he deserves better, don't you guys? Okay, well, I'm gonna put him out of his misery for a moment. Oh, he'll come back to life. He'll come back to life. He'll come back. He'll come back. He'll be back.
We'll revive him.
We will revive him.
Frankenstein's monster. No, just turn him right out of that.
Yes. We have the technology to rebuild him. Okay. Oh dear. Okay, so that's all working good, and this battery pack seemed to work pretty good in this. So I'm going to tuck this battery pack underneath, and that's going to go inside like that. See, the original idea was that these would just like be kind of sitting on top of each other like that, but because I wanted to see, obviously, what's going on inside the robot, I kind of left everything kind of unattached, just because, you know, when you that's what you do when you first start prototyping stuffing.
Again, you haven't committed to anything. It's best not to make it perfect the first one. You can be tearing it all apart anyways.
Exactly. And I'm impressed. You know what? Well done, Past Jordan. Mm-hmm. You did it. You made the thing move. No smoke. That's an achievement.
Pat him on the head.
Yeah, Pat. I wish I could go back in time and pat him on the head.
Your screen.
Yeah, pat it through the screen. Good job, Past Joey. Got myself a cup. Be less of a savage. Okay, so what shall we do first, Alan? Okay. I'll show you the part in question that broke. It's this one right here. So this is one of the leg pieces, and that was pretty demoralizing having this part snap off after I just brushed it with my finger, because these pieces were hard to bend precisely. If you guys can see that these bends that I put in there, that was from like taking it out of hot water and then like kind of bending it with pliers to get it into that shape. And the result is something that was kind of brittle. Here, you can take a look at it.
Yeah. So so the thing is with the 3D print plastics, it's either PLA or PTG. Mm-hmm. The transition temperature of them is roughly around Celsius, and we keep them up in boiling water is enough to bend them to.
Yeah, and this was good enough for like our starter project or whatever. But what we really want to do is we want to try and get a nice working spider body that we can have, more permanently house the servo motors, because this was not a good solution for us. I think that the idea was that like you could do it in like a classroom, and then everybody could just bend their own pieces of PLA. Just the PLA itself, it didn't want, like, after it was bent, you guys can see it, like here, I barely touched it with my finger and it broke. It's shattered. So I don't know.
Probably PTG would be better, because PLA is known for being hard and brittle.
Yeah.
Especially when it gets dry. Obviously, with moisture.
Mm-hmm,
so,
and I think that was also because I had done it multiple times, and the bending process, like getting it like back and forth, and then you kind of bend it once. If you do that more than once, it compromises the structure.
It deforms it permanently.
Oh, do you want to come sit on the couch? There's a kitty cat here.
I won't sit on kitty.
Do you want me to extend the picture so that you can see it?
Should be fine.
You're just a disembodied voice at this point. Fine. I can turn this off. There you go. Now it sees the whole room. There you go.
Turn the camera slightly.
How do I lurk?
You gotta do exclamation mark lurk. There you go. Now we're both in the picture. Look at that. There you go. Okay, so now should we talk about some of the theory behind what we're doing here on the paper?
Mm-hmm. Yep, so we can talk about what our current status is. So what are we going to build next? I guess we're going to build maybe the walk cycle on this and print up something later.
Yeah, as long as you just leave it open. I guess the thing would be to build the walk cycle, but I guess I didn't realize how bad it was. It kind of also needs like a body rebuild. So maybe we'll do that tonight, is try and do a body rebuild and print him some new pieces. Right. I do have one thing that I realized that we could do is I saw this one guy's design that used screws. So if we can use screws it might be easier to make those right angles of the leg pieces.
Yeah, so we actually you use them as pivots and stuff. So I guess let's think about where we want to go from that point.
Okay, sounds good.
Okay. So perhaps should we open up Thingiverse and let people know where that is, or
yeah, let's do that. I'm gonna try and find the actual design that I was using before. Or not this one. This one had some issues. I think the one I'm gonna try and do is either this one or that one. I think that this one uses screws. Well, this one looks like it doesn't use a lot of PLA. Maybe we should use this one.
Okay, we can try that one.
This will be our prototype design anyways. It looks like it uses barely any PLA. It doesn't look like it uses screws either. Oh, no, the screws here.
Those are just structural to hold it together.
Okay, so should we share this in the Twitch chat?
Sure, let's share it so let people know what we're working on.
Okay, I'm gonna share this in the Twitch chat so you guys can see. Or what? Actually, though, maybe I should take a look and see what parts this one requires before I share it. Oh, this is a really cool one. I really hesitate showing my computer screen because I'm worried like I share something I'm not allowed to share.
Let's see. You should be able to only share the clicker tab, I believe.
Yeah.
That way you don't have to share the whole screen, just only this Chrome tab.
Oh, yeah, you can do that, right? I don't know how to do that just yet, but should we do this one? It says the screws, or I can see the screws.
That's just to hold it up, I believe.
It doesn't say which pieces it needs.
So it looks like there's
here we go.
Pieces.
2 3mm by 6mm screw. Do we have those?
Well, we hopefully have them.
I'll have to take a look downstairs. I know that we have a bunch of, I think, 6mm screws. I just don't know the length.
They're all M3s. So the first measurement is the diameter. So on M3, so 6mm is how long they are.
Okay. Okay. So should we try this with this one?
Sure.
Okay.
So are people seeing what we're doing?
No, but I have to share this tab. How do we do that? Like window capture? And it would be like specific Chrome window or Chrome tab. Although showing all the tabs right now. Is there a way to show the specific tab?
I guess maybe it doesn't. I guess it doesn't. Well, actually, we'll just drag off that particular tab in its own window, and that way you can share that by itself.
Oh, I see. I see what you mean.
Yeah.
Now we're learning. Uh-oh, I think I just accidentally... No, it's here.
Yep.
I can take this one. Yeah, now it's just the one screen. I gotta move this underneath everything. We'll temporarily mute the droid cam. Surfing on the web. Maybe make this smaller. And filter on this guy. And I'll keep changing the pad, but and now we can our thing. So this is the one that we're going to try and use. It looks like to me, I see that this doesn't use a lot of material, so that means that it's viable that we can like print up some of these parts and
do really quickly as well
and test them up, right? So we're going to do some rapid prototyping, and then in the future we can try and print up a more advanced body. Again, I probably want to try and like actually design my own whole thing, just because like it'll be what the droid looks like, right? So I want to try and design our own.
Mm-hmm.
And if you guys have any suggestions, make sure to join my Discord channel and post some picture suggestions of what you guys think this spider droid should look like. Okay, let's go. Let's download. Are the ones that we have 9G servos? I think they are.
Yeah,
right?
they are. Yeah, these are 9D servos.
Okay. What are these other ones? Oh, these are Arduino files.
Oh yeah, it looks like you provide OpenSCAD files that you can edit them yourself if you want to.
Should I get those?
The Inno file. Yeah, that's the code. Yeah.
Yeah, grab that.
Mm-hmm.
Should I take these other files too?
I guess they're optional because they're not needed to print. They're just if you want to redesign stuff yourself. Maybe I might grab it and bookmark it so that we can return to it later, possibly.
Yeah. Okay.
Mm-hmm.
So, what should we start with? I guess one of the light pieces first.
That should be enough. So that we can fit it on our motor. See if it fits.
We have to add share Octoprint now, right?
Mm-hmm. Well, I actually want to share Prusa slicer.
Prusa slicer.
I want to show people how to slice it, or maybe we'll minimize stuff and share the desktop, or maybe we can create an alternate desktop possibly, or.
Because I can create a thing here for doing desktop.
Mm-hmm.
Oh God.
I just realized something.
Mm-hmm.
I just realized you can go on Chef's Plate and review how to do the recipe.
Yeah, videos?
By.
Mm-hmm.
So technically you could screenshot all the recipes you're interested in.
Yeah, but the whole point is that you try them out and then you're able to try before you buy in a way.
Yeah.
I'm not figuring out how what we're trying to do again, Ellen.
I guess we need to. We're going to have to share people Prusa slice and also Octoprint. So I guess we probably want to share the desktop. Or have you ever created an extra desktop for yourself? You have a lot of stuff on your desktop.
I have tons of stuff on my desktop.
Okay, we'll skip that then. So it's just
this is just the actual screen.
Sure.
So here we go. Now they can see the actual screen.
Mm-hmm.
I'm just going to open up Octoprint.
No, we actually want to open up Prusa slicer.
Prusa. That's not even how you open up Octoprint. You do it through the through the local network.
Mm-hmm.
Ooh, new updates. Download install.
Yep.
This looks like a pretty cool design. I don't see it. Like these pieces are all printed with these right angles pointing straight up. So I don't think there's going to be that. Yeah. My whole thing is like, how do you slip the motors in? I guess we'll find that out soon.
Mm-hmm. Looks like it just slips. It looks like it's a hole and it just slips in underneath.
Yeah.
That's what it appears to be. There's a rectangular hole and the whole unit kind of slips through.
Ah. Put this over here. Oh, look at this! That looks like a friendly robot.
Yeah, there's like sensors.
Let's make this a little smaller. Oops, not that one. How big? There we go. Okay, like that. Cool. There we go. Us. No. That. There we go. So now we've got our droid here. We're gonna try and print off some of these pieces. Let's get it going. So we're just gonna install some updates here, and we also got to activate Octoprint. Does it matter if?
It shouldn't really matter. Yeah, you should be able to open it up.
If I activate.
That's correct. And then we'll scroll down and let people see the printer.
Here's their printer. Cool thing is like The webcam was a major upgrade for the printer. Once we had Octoprint going, we pretty much needed the webcam, and that was like it made it so much easier to so that we can print stuff from upstairs and monitor how it's doing downstairs. That was a huge improvement to this whole setup. And also, this printer was born from the first printer we made, which is pretty incredible because we made a printer and then printed this new, better printer off of the other printer. Provided this one's like has its own issues, but it still
needs to be tweaked and refined. So I think there's some parts that are jamming still.
Yes. I'm guessing it's probably maybe this area here needs like some more adjustments or fine tuning. Because I remember that some of these screws didn't go in like perfectly. Nothing's perfect. That's why we got like those Prusa tools that let you adjust for skew and all this other stuff, right?
So the Prusa lets you kind of make adjustments, and actually I think Clipper does that too now. So we can actually put in the firmware. For
really?
Printer. Yeah.
Neat. All right. So what do we do next? We're gonna do
installing.
Oh, it's still updating.
Right.
It's still updating. We're going to wait for that, and I'm going to get these. Quadruped Eagle files.
No, that's for the breadboard.
Like
hurt. No. Big.
Sweet. We're gonna try to, I guess, print one of those leg pieces, or
let's print one of them first. Let's see if it fits.
We might not be able to print them all this time, guys. We might have to print them and then do it for next time.
We'll get it started that way. You see what the process is.
Here, we just want to open that in Prusa if Prusa is finished installing. Install. Go. This Prusa slicer was really good. I remember originally I was just using Repetier, and this Prusa slicer introduces a whole bunch of new stuff.
Oh yeah, we have to close existing Prusa slicer for it to update.
I think another thing I gotta do is I should do like a full reinstall and set up like a development environment for doing our Droid stream and stuff.
Or we create an alternate desktop or something. We do that in Windows.
I just know that like some things were like really easy to set up in Ubuntu, and some things were really difficult. Like that one thing with Arduino was not letting us.
Yeah, there was a security issue. It had to. Well, it had to talk to the USB serial port, but that's usually you need the administrator to open it up. Yeah, security.
It's really secure.
Yeah, because you don't want hackers getting into your network and sneaking information out.
Yeah.
Ooh, credit cards. Here you are.
I complain about it, but it's a good thing.
Get that through the little serial port.
Yeah. Okay, so now we've got Prusa. Let's run it, Prusa. Let's do.
Let's slice our model. Ask me next time.
Configuration of days available. More.
Oh, no, that's for the actual Prusa printers. You don't need that.
Okay, so now let's grab that file here. Get in. Got one there.
Our default setting, which should be fine, hopefully.
Slice it.
Well, slice.
Combine infill. You know that you can. Oh my gosh, it's the annoying paperclip. Combine infill. Did you know that you can print the infill with a higher layer height compared to perimeters? Say print time using the setting. Combine infill every.
So yeah, that's an interesting setting. So, for example, normally when you 3D print, you You do the perimeter and do infill and stuff. Well, combined infill, it actually prints the layer and then it just doubles extrudes it, moves up a height, and then it does a thicker layer on top because.
Whoa.
And then
okay.
does the outer layer. So therefore, each layer is actually twice as thick as normal of infill.
Whoa.
Yeah.
That's pretty cool.
Yeah.
That's awesome.
Should
we try that?
Oh, I guess we could do that.
It'll make it stronger, right?
Yeah. I think it's oh, there it is right here. Increase it by 1.
So 2?
2. Good night.
Good night.
Good morning. I'll keep.
Okay, how do we save it now?
Oh yeah. So then.
Right here, modified. We gotta do 2 between normal. This is gonna be infill every.
I guess so. Combine infill.
Combine infill 2.
Yeah.
Here's.
Say 2.
Okay.
Right. So we will.
Oops. Plater. Slice now. Okay, so now you guys can see that the model has changed a little bit. So this is actually explaining to my computer how stuff is printing. So like these lines in here show the path of the printer head as it's going through and printing everything. Really cool. This red stuff is the actual infill. Just trying to see like did it change how it's built here?
You have to scroll. If you go to the left edge, you can actually see the layers. So you have to click and hold, and I can see the internal. Yep.
Oh, okay.
You notice that if you look at the infill, you notice that it happens every twice before.
Oh, whoa. That is kind of cool. That's really cool. Okay, so that's new. Okay, let's send it to the printer now. Upload and print?
Yep.
Go.
Completed, and then we have to go to a web browser and open up our monitoring system using Octoprint.
This.
Check the up and see the temperature is increasing. Yep, the bed is increasing.
Sweet.
Cross fingers and wait for it to be done.
Okay.
In the meantime,
we have to discuss what we got to do, what we're actually going to make the program do, and I guess we should open up Arduino and give it a whirl, right? This is going to take some time for it to print. How long do you want to go till on 2 or 3?
What time is it now? So it's
almost 2.
Well, it's almost 2. So we'll set this up. Maybe give people a taste of it.
Okay, sounds good.
And see how it is.
Okay,
I don't
so
know if you have your existing code.
the one that was the wiper one.
Yeah.
Oh man, where did I save that?
Maybe we'll just do a fresh, but we should create a new folder and just save it in some particular place we can find. Quadruped. Where? So let's not put it in Arduino. Let's just put it on the top level because for drones. Maybe we'll call it Quadruped. You have your planning, but I guess we're going to put a folder called Quadruped.
I have no idea where I would have saved it.
Yeah.
So, why don't we just talk about the theory and how we're going to get actually try and get it to move.
Okay.
And let's go back to that. Let me change the stream here. So we're doing back to paper, right?
Yep. There
that's
it
another
is.
one.
We have to resize it.
Everything's like way off. I guess we don't really need that. There you go. That's the one we wanted, right?
Yep.
Here. Hey guys, I'm still getting used to readjusting everything like this. Okay, I think that's good.
Yep. camera. So maybe I'll adjust it. No, that's just the brightness of our angle. Yeah. The screen's actually fine, but it's the yeah. Looks like it's actually good. It's just the inexpensive second monitor we have. Alright, so then what we have is that we have the Quadruped, and we're using what's called Servo Motors. What is Servo Motor? Well, it's these little motors that look roughly the shape. Oh, let me change my pen.
Nothing's going right for us today. That's okay.
In this case, first off, for this particular kind of stream, it's not like a game stream. We just sit back and just do nothing.
Yeah, right.
So this is a little servo motor. If we could take it out of this thing, it looks like this. And you notice this little thing above. Well, this is a little hub where we have the axle. And this little white axle, it actually can swing back and forth, usually around 180 degrees, back and forth. And they come usually with these little attachments that let you more easily attach other things. So we're going to put one in like that, and it goes back and forth. So we have a wire. You notice, what does the wire do? Well, this is actually how you control this thing. So it is a 3-wire setup. So we need to supply power to this thing. So typically that would be, if I recall, that would be like that brown was ground. And then we have red is usually power supply, usually in this case up to I believe +5. And the third line, the orange, this is the control wire. So how does it work? Well, what happens is that you have this plugged into, in this case, our controller board, or if you have a model airplane or a model helicopter, model boat, and also another controller. Power gets applied. This gives it the ability to move back and forth. But how do we make it turn the control? So it is you send a little pulse to it, and depending how wide the pulse is, the more this moves to a particular angle. So short pulses are small angles, and then a larger pulse is equal to a wider angle. And by varying how wide this pulse is, it changes to which position this moves. That's how servos work. The timing is actually pretty small. You only have about, I believe it's about 20 milliseconds of each pulse.
But that actually never made any sense to me. Is like how that one wire changes the angle somehow.
The thing is that inside there's actually a little microprocessor inside.
What, really?
Yeah. Yeah.
Really?
Yeah. So inside here, there's a little. So what's inside here? It's a couple of components. There's actually a motor inside, but also there's a little microprocessor, a little chip inside. There's also a potentiometer as well too, which detects the angle this is in.
What?
Yes. So there's a whole kind of control system inside.
Interesting.
A feedback control system. So what happens is that.
Oh yeah, you were mentioning before that we can make our own servo motors with like just DC motors, right?
Yeah, you can. So all you need is you need somebody to get feedback to know what position, and then if you know position, you can vary the current, make it go whatever you want to.
That's super cool. That's super cool. That would be a project in the future, is to try and make our own servo motor.
Yeah, there's actually some designs in Thingiverse
that'd be cool.
Make massive your own servo motor.
All right, guys, you guys heard that. if you guys want us to make our own servo motor as a project, make sure you guys like and subscribe, or donate. That helps too.
Control wire.
Thank you guys.
Pulse width determines angle this turns. But yeah, so the pulse goes in here. This microprocessor measures how long the pulse is, and if it's I actually think it's 2 milliseconds. Yeah, actually, I'm trying to remember the exact pulse. I have to look it up. I think it actually was 2 milliseconds. So if it's set to 2 milliseconds, that's considered 0 degrees. But if it's up to 4 milliseconds, that's considered 180 degrees. And any kind of pulse width in between determines, what sub angle of that is.
That's insane because like it seems like it's able to just jump to certain angles, and all our Arduino has to do is tell it the angle that it wants to be.
Yeah. So it is. It
doesn't have to do anything hard.
Yeah. So this is why they were used in model control airplanes for so long. So it's a very easy control scheme with this little pulse, saying how long it is determines what angle it is. So maybe this is equal to 180 degrees, but this is equal to 0 degrees. You have something intermediate, like that would be equal to 90 degrees.
That's fascinating. So it can tell just by the width of the pulse exactly the angle that it's supposed to be at.
Yeah. So then it just tries to move it to that angle and tries to maintain as long as it gets
That's
a consistent
crazy.
pulse of that.
Let me pull out the servo motor inside here. Let's take a closer look at this guy.
Yeah, but you can actually see through the housing. If you look carefully, you can actually see the internals.
Yeah, because the body of it is like translucent a little bit. So let's take a closer look at it.
Next time we should provide more lighting in this area.
That's okay. You can bring over the stage light a little closer if you want to.
Ah, okay, there we go. So I don't think you can kind of see inside.
Oh yeah, you can see. There it is.
Very carefully. If you just get the reflection just right, you can see little chips inside. One's a microcontroller. I think, yeah, that's a microcontroller right there. That little rectangular package right there.
Oh, I see it. I see it, guys. It looks like a little tiny inside there. It's right.
Could even be that tiny. I don't think if we can enough light, you can actually look at it close and just see if it might actually be that tiny.
Let me take a closer look.
Yeah. If you can read any info on that chip or not. Looks a lot like that
says 117L 926.
That might be a that sounds more like a power controller.
117L 926.
Typical L stands for linear or stuff that's analog.
There's a lot of gears in it.
Yeah, because the motor is so small, and in order to get enough torque, it has to gear it down a lot.
Yeah. Wow, this is so cool. Remember, we were making motors before with that other one that we made. We actually made a pretty powerful motor.
Yeah, we made a little kind of a gearbox package using the little tiny, I guess, toy car motors.
Man, that thing was insane because we were able to make it go so fast, and it had a lot of power to it. It was more than enough to like straight up crack a gear in half.
Yeah, so there's a little potentiometer. I think that the orange, the little yellow package, I think it's a potentiometer, measures the angle.
Oh, so wow. That's what that is, huh?
Yeah, so then as a twist, it's able to measure the angle, that's it, and stop it or at that point, and so on.
That's fascinating.
Yeah, so then that's how the feedback works.
Okay, so these servo motors are what we're going to be basing our quadruped off of, but I do actually have like a couple different ways to control these servo motors. So you can actually run the servo motors directly off of the Arduino, or you can try and control them using some sort of control board. I decided to opt for the control board because of the ability to kind of power the control board externally, and also the control board's kind of flexibility. I could put more servos if I wanted to. I could do, less. Now the control board is that TLC 5940, which we have here on this guy. This control board here. And you can actually see that all of those servo motors are actually hooked up in like rows here. These are these little bundles coming off of it. Those are the servo motors that we're controlling. Now, one of these servo motors is not that much power. One of these guys only uses, I don't know, maybe a couple hundred milliamps at most. But when you have like a bunch of them, like you can see here where there's a lot of them all running together, they very quickly add up. If let's say that these are 200 each, so like assuming that the other ones are hooked in, so 200, 400, 600, 800, 1000, 1200, 1400, 1600. So you're looking at it's pulling like 1.6 amps.
Yeah, there's quite a bit of current for that to handle.
Especially if it's like stalled out or something like that, it's actually going to pull that amount. Which means that this little pack here is going to die pretty quickly if it stalls. But if it doesn't stall, then this could still be pretty much enough. But that's the reason why we were running it off of kind of those more hardcore battery packs that you guys might have seen in a previous video. But that's all. That's probably all we're going to do for tonight, guys. I hope that you guys enjoyed that. If you guys like it,
let's people see the printer going.
Oh, right.
Yes.
Yeah.
Before we head off.
So
we're printing a leg.
Oh, we've got to move all this stuff out of the way now.
Oh, it's working.
Here it is.
Yes, there we go. We're printing a leg. It's going to take a bit longer, but we have to print a whole setup. And next we're going to do some assembly and revamp this one. Hopefully, with a better skeleton, it's able to move more effectively.
My whole thing is like we streamed the thing moving, and prove that I actually did make it work.
Mm-hmm. Oh,
it was crawling, it was writhing in pain. it was. Oh, help me, Daddy! Help. You know what? Should we hook it up one more time to see it writhe again?
Yes.
Let's do it again. I was proud of that writhing. Here we go.
I think it died.
Did it die?
There it is. Some loose wire somewhere.
Oh, it's one of these wires here. Let me push all these ones in. Oh, that's the white wire. The white wire is like one of the signal wires.
There we go. It's kind of jittering. It's pretty horrific, but it proves that we did something.
Yeah. It also proves that we can get this thing moving, which the next step after getting it moving is to get it walking. Because it's moving, it's alive.
Yes. And
that to me was a pretty major achievement when I first did it. I just like the next step, which is trying to get it to walk, seemed a little bit intimidating until you broke it down into steps. And I think that for a lot of beginner engineers, that's a good thing to remember, is that everything seems intimidating until you break it into steps, guys. And thank you guys so much for watching. This is Jordan Vo, and if you guys like that, please remember to like and subscribe. Check me out on YouTube, and that is all for now. Thank you guys.
Enjoy your night.
And have a great night. Bye, guys.
Bye.